Testing. Selamat sejahtera semua. Okey. Selamat sejahtera semua. Okay, selamat sejahtera semua. Hari ini kita akan masuk, revision SK015 Chemistry Chapter 4 Chemical Bonding. Okay, good evening everyone. So, we shall start our class soon. Okay, so everybody, before we start the class, right, just take a piece of paper and a pencil because later I will ask you all to draw something. Okay, so get ready for it. Okay, if any problem, right, you just write over the comment. I will check the comment. Okay, so let's start. As usual, have you subscribed my channel? If you haven't, please subscribe now. Just press the button, subscribe, like, and share. Thank you very much. Okay, and then this one we discussed before. So this is the continuous assessment. So I think you all should be no problem already. Okay, today we are going to check for chapter 4. Okay, we are going to check for chapter 4, chemical bonding. If you check, right, the highest weightage is chapter 1, 21 marks. After that is chapter 4. Then followed by chapter 7. Okay. Then this is the target that I shared before with you all. So please make sure that you can score more than 60 over 80 if your carry mark is 50%. If not, right, if your carry mark is lower than that, so your final exam have to score higher. Okay, so this is our main discussion for today. So before I go to our main discussion, so I just want to double check the slide is clear and then the sound system is clear. Is it clear? Everybody, someone please write down, comment. Okay, thank you, Aiman Hamza. Okay, very good. Everything is clear. Natasha, thank you. To, thank you. Okay, so let's start now. Okay, so the first one is restructure. Okay, this learning outcome is from the lecture notes. So we just have a quick review for these 6 subtopics. Okay, the first one, Lewis dot symbol. Lewis dot symbol is very important. Why? Because later when you want to draw the Lewis structure, you have to identify the valence electron of the element. Because if group 1, 1 dot, group 2, 2 dot, 13, 3 dot, 14, 4 dot, and 18, 8 dots. So if you're not sure what is the valence electron for the element, right? No choice. You have to start from electronic configuration. Okay, so before I proceed with the electronic configuration, I want to share this one with you all. Okay, so this is the table of relative atomic mass. Please take note. Okay, the first one is the element, the full name of the element, and then the second one row is the symbol. Okay, for example, aluminium is Al, and third row is proton number. Okay, proton number is the number that you are going to use to write down the electronic configuration based on the electronic configuration to identify the valence electron. All of this you learn in chapter 3, periodic table. And then the last row is the relative atomic mass. Okay, if you follow my tips and tricks for chapter 1, you know, okay, actually the relative atomic mass and the average atomic mass have the same value. So please be careful. While you get the table of relative atomic mass, please check. Here, proton number is for the electronic configuration. Okay, and then this one is for calculate the number of mole. Okay, another one is about here. Okay, you have to check the list of the selected constant. You no need to memorize the speed of light, Avogadro number. You just check the value over here. Okay, okay, this is what I want to tell you all. Okay, let's proceed. Okay. So if possible, right? Okay, group 1, lithium, sodium, potassium, you should know already one valence electron. Okay, next, octet rules. Octet rules is talking about duplet and octet. The duplet just for the hydrogen and then octet for others atom. Noble gas electronic configuration which is stable. Normally we are talking about NS2 and NP6. Okay, next is about the formation of chemical bond. For the formation of chemical bond, there are two. One is ionic bond, another one is covalent bond. Okay, you have to be clear. Ionic bond is transfer of electron. It's the reaction between matter and non-matter. So one of the electron from the matter transfer to the non-matter. Once the matter transfer the electron, it will become the cation. And then for the non-matter will accept the electron. Now it achieves the octet. Always remember there are 8 dots when you form the ionic bond for the non-matter. Students will always forget about the dot. Okay, so make sure the non-matter there are 8 dots with negative charge. And then the cation without any dot already. So because it's donate already. So that's why it's positive ion. So the other names for ionic bond is electrovalent bond. And then for covalent bond is sharing between non-matter and non-matter. Okay, so 2 electrons equivalent to 1 bonding. Okay, actually under covalent bond there is another bonding. We call it as coordinate covalent bond or dative bond. Okay, the concept is still the same, sharing. But for this case is donor atom has a lone pair electron, means 2 electrons. Acceptor atom has an empty orbital to fill the 2 electrons. So all of this, right, is the example from your lecture notes and tutorial. Most important, you must show the arrow. Okay, when you form the bonding, right, you must show the arrow. The question always ask about, please show the dative bond and then label the dative bond. You must show the electron is from the donor to the acceptor. Here, please take note. So this is the example of dative bond. And you always have to remember, this is a H plus ion. Okay, when it accepts the electron already, so the whole structure, the whole molecule must be the positive charge as well. Okay, so H3O plus. Students will always forget about the positive charge. Okay, same for ammonium. Okay, this is another example. You can refer back to your tutorial or lecture notes for others example. Okay, let's try this question. If the question asks you identify the chemical bond of ammonium azide, NH4N3. So meaning that you have to identify whether it's ionic bond or covalent bond or dative bond. Okay, for sure the answer is ionic bond. But before that, you have to know this is the structure for ammonium azide. Because NH4, you have to know that actually this is NH4 plus. Okay, you should be familiar with ammonium, but you are not familiar with N3. The N3 is negative. Okay, so this is the ionic bond. Based on this structure, the question can ask you other things. For example, show the formation of dative bond for the cation. Please be careful, the question asks about cation. Okay, cation, and then very clear, dative bond, meaning that you have to show one lone pair donate to the H plus. So it forms the dative bond. Okay, another question may ask you, okay, show the formation of covalent bond for the anion. Okay, and then since there are double bond over here, right, double bond for the central atom, it can form resonance. That's why the question can further ask you about, draw all the resonance structure for the anion in the above compound. State the most stable resonance structure. Okay, so you know, even a simple structure, a simple question, but it can ask many things. Okay, of course, when the question asks you about show the formation of covalent bond for the anion, covalent bond, meaning that you have to know how to draw Lewis structure. Okay. So next we proceed. Okay. So this is the main part to help us to proceed to answer the consequence of this chapter. You must make sure that you know how to draw correct Lewis structure. You must remember all the 5 steps. Okay, central atom, choose the positive one, electropositive one, count the valence electron. So normally students no problem to identify the central atom, but some of them might careless to count the valence electron. Okay, so while you please double check for the valence electron, means you have to refer the Lewis dot symbol. That's why I just now the first part I'm talking about the Lewis dot symbol. Okay, then second part, draw single bond and calculate the non-bonding electron. Complete the octet for the terminal atom. place any remaining electron at the central atom. If the central atom haven't achieved octet, then you have to form double or triple bond. Okay, so this is the rules you have to follow tightly. Okay, another part is about the formal charge. So this is the formal charge for a formula of the formal charge. Total number of valence electron in a free atom. Okay, means phosphorus 5 valence electron, chlorine 7 valence electron. Okay, minus total number of lone pair plus half times total number of bonding pair. Always remember, one bonding pair equal to 2 electrons. Okay, so let's check. This is the example from your lecture notes. I'm using the lecture notes example. Just revise. Draw the Lewis structure of NO2+. Which of these Lewis structure is the most stable? Definitely you will know. The step 1 is draw the Lewis structure. Calculate the valence electron 5 plus 12. Okay, positive charge minus 1. Okay, and then total is, yeah, there's something I have to adjust. So the total is 16. Okay, so the total is 16. Okay, 16 minus 4 because form the bonding pair. And then minus 12 for the terminal atom, for the octet for the terminal atom. Okay, most of the students will assume, oh, finish already. This is my Lewis structure. Okay, you have to always check for the central atom. The central atom haven't achieved octet yet. Student quite careless for this part. Okay, the central atom haven't achieved octet yet. So you need to try to form the double bond or triple bond. Okay, to ensure that the central atom is octet. So you can form like this. Okay, the blue color structure is resonance, is the same. So we just draw one, and then this one is double. Okay, there are two structure. So now you have to identify which one is the more stable structure. Then you have to calculate the valence electron. Formal charge. So you have to calculate the formal charge, and then structure A is more stable. You check for structure A because it has the lowest formal charge. Okay, what I want to tell you over here, right, is there are two structures. You choose A. That's why only with one reason. If we proceed for the next, okay, you check for this structure. Okay, S and N, both terminal is different. That's why I can form single, triple, single bond at sulfur, and then single bond at nitrogen, or double bond. Okay, there are three structure. Okay, when there are three structure, your reason, okay, you will choose structure C. Okay, you compare. Oh, between B show out already because had higher formal charge. So you won't choose. So it has lower formal charge if compared with structure B. And then A and C, both having the same formal charge, -1. Then why I choose C, not A? And then now you choose C is due to the negative charge is located on the more electronegative atom because nitrogen is more electronegative than sulfur. Okay, yeah? So the point number 1 is talking about central atom haven't achieved octet yet. So you try to form the double or triple bond. So when you try to form the triple bond, double bond, then there are three choices. Okay, out of three you have to choose one. That's why you have two reasons, okay, to explain why you choose structure C. Just now, with one structure, two structure, compare among two structure. That's why only with one reason. If compare among three structure, must have two reasons. Clear? Clear? Okay, and always remember, central atom haven't achieved octet yet. Make sure octet. Okay. We keep on saying about octet. But there are three cases which not follow octet. Exception to octet rules. The first one is incomplete octet. When you explain the incomplete octet, the key point here is less than 8 electrons. And then this element or this atom is electron deficiency species, beryllium, boron, aluminium. If you check their formal charge, right, check for boron, actually it's equal to 0. Beryllium, 2 minus half times 4, okay, equal to 0. Aluminium also the same, 3 minus half times 6, okay, equal to 0 already. That's why they already achieved the stable state already for boron, beryllium, aluminium, even though there are no 8 valence electrons surrounded it. Okay, so please don't try to form the double bond for this electron deficiency species. Okay, next expanded octet. While you explain the expanded octet, you must mention more than 8 electrons. and involve non-metal atom of the third period onwards. Okay, only applicable for the non-metal atom on the third period onwards. Means 3p, 3d, 4p, 4d, and then 5p, 5d. Okay, because why is on the third period? Because the empty 3d orbital allow the electron from the 3s or 3p to excited. But for n equal to 2p, there is no d orbital. Okay, this one is related with chapter 2. So this is the main reason. More than 8 electrons, and then exits of the empty d orbital. Okay, and then the third one is odd number of electron in its valence shell, and then normally from group 15 and group 17. Okay, nitrogen, chlorine. Okay, always check for the formal charge. If the formal charge is equal to 0, right? Okay, normally it's stable already. Okay, now we check for this question. Okay, normally the question will ask you, okay, the main point is over here. Why phosphorus can form PCl3, PCl5, but nitrogen can only form NCl3? Before they ask about this higher level question, they sure will ask you the simple question. First, draw the Lewis structure. So you have to draw the Lewis structure correctly. Just follow the step. Okay, because Lewis structure, you must show the dot for the terminal atom. Okay, and then why? Okay, this is the reason why. Why so fast? Sorry. This is the reason why. Because P phosphorus is in period 3 and then unoccupied MTD orbital. So the 3s electron can be excited to the MTD orbital to produce 5 single electron for form bonding purpose hybrid orbital. So this is related with hybridization. You should know already. But for period 2, N is period 2, there's no D orbital, so cannot expect. So that's why it only has 3 single electron and 1 lone pair. Okay, the last part for the first topic, the first theme, right, is resonance. So resonance, actually, right, this structure also has resonance. They are resonance. So 1, 2, 3, they are resonance. For this also the same. Okay, this is the resonance as well. Okay, but here we were looking for the double, a single, double, double, single. When you want to draw the resonance structure, you must show the double-headed arrow. Okay. And then if you want to represent these two resonance structure with one structure, and then you can represent by resonant hybrid. So this is the resonant hybrid. Okay, same for here. Okay, when you draw the resonant hybrid, must check this is the real line, dotted line, real line, dotted line. Alternate real dotted, same for here, real dotted, real dotted, real dotted. Okay, now we go for the second theme. Okay, the second theme, part B, molecular geometry and polarity. So if you look at this diagram, right, actually you're quite familiar already. Okay, so AB2 linear and so on. I don't need to talk too much, but you have to remember when you talk about this part, right, this molecular geometry, you must know the theory. The theory is come from valence shell electron pair repulsion theory. Okay, what is valence shell electron pair repulsion theory? So those electron pair are oriented to be as far as apart possible to minimize the electron pair repulsion. Okay, so there are 3 types of repulsion. Bonding pair is the weakest one, and then lone pair with bonding pair, and then the strongest one is lone pair. That's why the repulsion increase. Okay, the repulsion increase like this. Yeah, lone pair is the strongest repulsion. Okay, so one question I would like to ask: electron pair arrangement, is it same or different with molecular geometry or molecular shape? I think most of you know, right? The answer is different. Okay, this is one of the activities I have done with my student before. Okay, for part 2, part B, molecular geometry. Okay, I will ask my student to identify the class of compound. Okay, identify the electron pair arrangement, means the number of lone pair and number of bonding pair. Next, we have to draw and name the molecular geometry. What is the bond angle and what is the type of repulsion? before we proceed, you have to clear. There are 5 basic geometry you should know. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. These are the 5 basic geometry. Okay, and then you must always remember the bond angle. Okay, the bond angle of these 5 basic geometry, because the rest, right, they are lone pair. So lone pair will decrease the bond angle of the structure. Okay. Okay, that's all for this slide. This is I mentioned already, this one done already. Okay, sorry, just out here. Always remember the number of electron pair actually we just consider for bonding pair and lone pair. So number of bonding pairs plus number of lone pair equal to the number of electron pair. So, okay, look at this example. Just now I asked, right, what is the difference between electron pair arrangement and molecular geometry? Okay, if we check for methane, 4 bonding pair. This one, 3 bonding pair, 1 lone pair. 2 bonding pair, 2 lone pair. So sum of the bonding pair and lone pair all is equal to 4. That's why the electron pair arrangement is referred to the basic geometry. So there are how many basic geometry? There are 5. That's why you have to always remember electron pair arrangement is referred for the basic geometry. Okay, if you forget what is the basic geometry, we just recap a bit here. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Okay, and then the molecular geometry, we will look at the lone pair. If there is no lone pair, okay, the molecular geometry is still the same. Okay, if there are lone pair, if 1 lone pair, 3 bonding pair, the name is trigonal planar. If 2 bonding pair, 2 lone pair, the molecular geometry is band. So these are the difference between electron pair arrangement and molecular geometry. Okay, of course the bond angle sure will be different. Okay, so if the basic one, we just follow 109.5 degree. And then for there's lone pair, right, sure less than the basic, the original one. Okay, if you know the exact angle, you can write down 107 for ammonia, 104.5 for water. If you're not sure, you just write down less than 109.5. Of course, the type of repulsion for here is bonding, bonding. Here is bonding, bonding, bonding pair and lone pair. Over here is bonding, lone pair, then lone pair, bonding pair, bonding pair. Here, so I will write down 2. Okay, I will write down this one bonding pair, bonding pair. This one is, there are 2. Okay, please do some correction. Here is lone pair, bonding pair, and bonding pair. For this one, there are 3. Bonding pair, bonding pair, bonding pair, lone pair, and lone pair. Please take note. Of course, you have to compare the bond angle. Okay, for this one, we compare between the lone pair. This one is between the lone pair, bonding pair. This one is bonding pair. That's why the answer just emphasize on this, the difference for the difference type of repulsion for these 3 molecules. Okay. Okay, Dev, I am not getting it. What do you not getting it? Okay, I check the comment for a while. Okay, if you have question, right, please ask clearly. Okay. Okay. Now, okay, for the team B, for the part B, we go for the polarity. Okay, this is the format. Okay, I told my student. Okay, you have to check for the step 1. You have to check for the electronegativity of each atom. Second, symmetry or asymmetry. Next, check for the bond dipole, can cancel or cannot. After that, you check for the dipole moment, whether there is resultant dipole moment or not. Then only the last part is polar or non-polar. Okay, for example, in this case, before you start to identify the polarity, you sure have to draw the Lewis structure. After you draw the Lewis structure, okay, for those who hardworking, okay, you can spend more time, answer like this. Class of compound, electron pair arrangement, molecular geometry, bond angle. Okay, if not, you can straight away answer. Okay, if the question just 2 marks, you can straight away give the answer. For example, in this case, after you draw the Lewis structure, you know the molecular geometry is tetrahedral. Okay, what are you going to do is you have to identify fluorine is partially negative, and then nitrogen is partially positive. So the dipole moment is from the partially positive, okay, move to the partially negative, okay, pointed to the partially negative atom. Okay, so here, or go to the downwards. So there is a resultant dipole moment. Based on here, actually, you know already. For sure, this is non-polar, but you have to, for sure, this one is polar. Because cannot cancel off, there is a resultant dipole moment. But if answer the essay question, you have to mention, okay, fluorine is more electronegative than nitrogen. Each bond is polar. Because different electronegativity over here, that's why it's polar. At the same time, this one is not symmetry or asymmetry. So the bond dipole of NF does not cancel each other. So dipole moment mu not equal to 0. Therefore, NF3 is a polar molecule. Okay. Actually, right, there is some tips to share over here. We check for this slide. I always tell my student, right, okay, normally when you draw a structure without lone pair, it's referred to the basic geometry. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. If you get this structure, then you have to check the terminal atom. If the terminal atom is different, this is a polar molecule because the dipole moment impossible to cancel because different one. But if the terminal atom is the same, then for sure this is non-polar. Okay, I give you an example. The example normally for this case is, okay, for example, I use this one, C, H, 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 and then Cl. This one is tetrahedral, but it's polar because I cannot cancel over here. Different. The terminal atom is the different. Tetrahedral, just like I said tetrahedral. By right, okay, by right tetrahedral, okay, is symmetry. Dipole moment can cancel off each other. Mu supposed equal to 0, but due to this one, due to this terminal atom is different. That's why cannot cancel off. So it's polar. Okay, for this case, I am using the tetrahedral as well. And then the terminal atom all is hydrogen. Yes, this one, tetrahedral, symmetry. The dipole moment will cancel off each other. That's why mu equal to 0, non-polar. Okay. And then for the central atom with lone pair, normally is polar. Besides square, planar, and linear. For the AB3E2, when you draw the AB3E2, the AB3E2 should be like this. Okay, the suppose it's AB2E3. AB2E3. Okay, 2 bonding pair, and then 3 lone pair. Okay, check. AB2, 2 bonding pair. Okay, so this is a linear. Okay, so left, right cancel. Because when we determine the polarity, right, we are not check if the lone pair over here. We just check for the bonding pair, linear, left, right cancel. And then for the square planar, the structure will be like this. Okay, the square planar, the structure will be like this. This is the square planar. Okay, this cancel out with this. And then this will cancel out with this. Okay, so that's why even though square planar and the AB2E3 linear with lone pair, but okay, the dipole moment can cancel off each other. Mu equal to 0, non-polar for these two cases. Nadia Farisha, you're asking about how to know whether it is symmetry or not. Okay, if my student they will know already because I explained before. Okay, very quick. For all the basic geometry, sure can cancel off each other, but the term and condition is must with the same terminal atom. Okay, so linear, left, right cancel. Trigonal planar like this. Okay, it will form the vector. For these two will produce a vector. When it join together, it will produce a vector for downwards. That's why up, down cancel. is for trigonal planar. Okay, I just can explain in briefly with you all about these. If you for tetrahedral, the structure will be like this. Okay, the structure will be like this. Okay, these two will generate a dipole moment like this, left, right. Okay, these two vectors when joined together will produce a vector downwards, and then up and down cancel off. Okay, for trigonal planar, actually it's like this. Okay, this is trigonal planar. Okay, the shape for trigonal planar, up and down cancel. Okay, for this one, we produce a resultant dipole moment towards here. Okay, to the left hand side, and then left, right, cancel. Okay, octahedral very simple. Cancel like this, cancel like this, cancel like this. Okay, that's why all the basic geometry, as long as the terminal atom is the same, so it's considered as symmetry. Okay, mu equal to 0, non-polar. Okay, Nadia, Farisha, get it? Okay, now we proceed for the next. Okay, this is the main part for today's lesson. Okay, so now it's 9. So we are focusing over here. For the orbital overlap and hybridization, the first we need to identify the type of hybridization. Actually, very simple. Since you know the molecular geometry already, right? If linear, the type of hybridization sure is SP. Trigonal planar, SP2. Tetrahedral, SP3. Trigonal bipyramidal, SP3D. And then octahedral, SP3D2. Okay, what is hybridization? Hybridization is the missing between the orbital. Okay, why this name is SP? Because it's the missing between S and P orbital. One S and one P orbital. This one is one S and two P orbital. This is one and three P orbital. Okay, and so on. And then the second part is the central atom. You have to know how to draw the orbital diagram for the central atom. Ground state, excited state, and hybridization state. Many students will encounter problem over this part, especially for the molecule with ion or the molecule with lone pair. Okay, orbital diagram for terminal atom is normal nothing. Normally is 1s or 4 ion, 2s2, 2p5. That is drawing. This is another part student will facing problem in drawing. Explanation should be no problem. If you understand the concept already, you should be no problem to explain the whole drawing for the hybridization diagram. Here, just now is the step for the hybridization and overlapping diagram. Before we start with the step 3, step 4, step 5, step 6, and step 7, which we discussed just now, you must make sure that you can draw the correct restructure and you know how to determine the molecular geometry. Okay, these two that you learn in part B. If your restructure is wrong, normally the rest of your answer scheme, teacher will be very happy, can be bangga already. Just make a cross. So I hope you all, step 1, master for the step 1, correct restructure. The last part, you have to check, make sure the shape is correct and labeled completely and correctly. And then your diagram must tally from A until Z. That's what I like. Actually, I like chapter 4 because chapter 4 is very easy. If once your step 1 is correct, right, and then it's tally with your step 7, meaning that your answer is correct. Okay. So we are going to discuss the overlapping by using these 6 examples. Okay. And then for this part, right, there are a few keywords. If the question asks about state and label, it's a simple question. State, you just state. For example, the question asks you, what is the hybridization for this molecule? You just state SP, SP2, SP3, that's all. If the question asks you label, you just label. Label for the SP2, label for the SP3, and then label for the dative form, just label. But for draw, show, illustrate, explain, describe, right? For these 5 keywords, you have to do many things. you have to repeat the step 1 from A until Z in order to score full mark. Okay. So now we start. Okay, for information, right? The answer for this part, right, I'm using my student answer. Okay, so you try to identify their mistake as well. Okay, so the first one, sp6, FPF6 negative ion. Okay, I just recap a bit. Determine the central atom. Calculate the total number of valence electron. Okay, I not encourage you all write down E. Just write down the full term, electron, valence electron. If possible, write down valence electron. Okay. If possible, right, I prefer you all write down the full term, valence electron. Okay, valence electron. Okay, please write out the full term. You don't give the chance for the examiner to penalize you. Okay, write down the full term. Total number of valence electron, total valence electron number. Okay, so sp is 5, and then 6, 7 valence electron with negative 1. Okay, the charge is negative 1. That's why you have to plus 1. Total 48 valence electron. So central atom 1, 2, 3, 4, 5, 6. So minus 12 equal to 36. Make sure all the terminal is octet. 6 times 6, 36. So equal to 0. Okay. So this is the complete restructure. Always remember, must write out the negative as well for the regressor bracket. Okay, so this is a proper one. Okay, this is a nicer one. Okay, step 1. Step 2, molecular geometry. You check. So the class of compound AB6. A is referred to the central atom, 6 is referred, B is referred to the bonding pair. So the electron pair arrangement, is 6 bonding pair plus 0 lone pair equal to 6 electron pair. So always remember, for the electron pair arrangement, just refer to the basic geometry. Okay, means linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. So over here, there are 6 bonding pair, 0 lone pair, total 6 electron pair. So this is octahedral. So this is the bond angle, type of repulsion, bonding pair, bonding pair. Actually, right, the type of repulsion is not compulsory here, but I teach my student in the package, so they just write down like this. Okay, next. If you want to write the short form, right, bonding pair, you write down the BP, right? Okay, you must write down here, let BP equal to bonding pair, lone pair, LP equal to lone pair, electron pair equal to electron, EP equal to electron pair. Okay, you have to clarify. If you want to use the short form, you must clarify. Okay, one more thing. Once you know the molecular geometry is octahedral, you have to redraw the structure. What is the difference between restructure and molecular geometry? The difference is there's no lone pair for the terminal atom. Okay, and then here must with charge. Here is a similarity, both must with a charge, negative charge. Because starting from here is negative, so your restructure must with a negative charge. Molecular geometry must with negative charge. For your hybridization diagram, also must draw the negative charge as well. So step 3, 4, 5, identify hybridization. Actually, in this case, you should know that what is the hybridization already. 6, sp3d2, octahedral, because this is octahedral. As I mentioned just now, linear sp, trigonal planar, sp2, and so on. So this is octahedral, so you know already it's sp3d2. For this one, hybridization, the easiest way is identify the basic geometry, means the electron pair arrangement. Okay, Nadia Farisha, of course. Okay, Nadia Farisha asked me a question. If the question asks about hybridization, do we have to show the restructure and molecular geometry? Dear, it's a must. Okay, must. If the question asks about hybridization, you must start with step 1. Okay, I repeat. Since there are students ask this question, meaning that got someone is not clear. Okay, I have to repeat again. These are the steps to help you to draw orbital overlap and hybridization. But before you know how to draw the orbital overlap and hybridization, you might start with 1, correct restructure. And then step 2, molecular geometry. Okay, because restructure, when you draw the restructure, you're not sure the shape yet. Only when you identify the molecular geometry, then you only know, oh, this one is octahedral, this one is trigonal planar. Because when you draw the hybridization diagram, right, for the drawing part, you have to always tally with the molecular geometry. Okay, the diagram of the molecular geometry, the shape of the molecular geometry actually is tally with your hybridization drawing. Later we check, yeah? So clear? Natia, Farisha? Clear? Okay, so now we proceed step 3, 4, 5, then 7, drawing and explain. Okay, so this is the step 4 and 5. Orbital diagram for the central atom and terminal atom. Okay, why suddenly formal charge is here? Because I want to show you the SPF6 negative. The negative is belong to the SP. Okay, if you check for the valence electron, SP actually is group 15. Okay, there are 5 valence electrons. But there is an electron, there is a negative charge, sorry, there is a negative charge here. Meaning that is SP is not an atom, but it's an ion. It's an ion. Okay, that's why so the valence electron for SP negative is 6. So 5s2, 5p, 4. Okay, always remember follow Hans rule. Okay, singly fill first, then only pair up. Don't give me 2, 2 over here. No, 2, 1, 1. And 2, completely fill, unpair. Because this is also one of the common mistake of the student. They straight away orbital diagram. Oh, there are 6. So 2, 2, 2. So sorry. Then you will lost 1 mark for the orbital diagram. Here, must follow Hans rule. Singly fill first, then pair up. Okay, now when you draw the orbital diagram for the central atom, you have to tally with your structure. Just now, there are how many bonding pair? The answer is 6. But only there are only 2 unpaired electrons. Okay, actually easier. I have to show you here. I have to show this one. You check. 1, 2, 3, 4, 5, 6. You need to form 6 bonding with the foreign atom. That's why you need 6 unpaired electrons. Okay, but here only 2 unpaired electrons. That's why you need to excite it. So the electron here, over here need to excite it. The electron over here need to excite it. So it will excite it to here, to the d orbital. Okay, excited to the d orbital. Okay, after it excited, right? 1, 2, 3, 4, 5, 6. Now it can form 6 bonding with the 6 chloride ion. Okay, that's why I say your restructure must tally with your molecular geometry, and then your orbital diagram of the central atom and terminal atom also must tally with the drawing in restructure and molecular geometry. So now we check for the hybridization state. Hybridization state is referred to the bonding pair and lone pair. In this case, there is no lone pair, so just bonding pair. There are 6 bonding pair. So 1, 2, 3, 4, 5, 6. So these 6 orbital will hybrid from the sp3, 1, 2, 3, p2 hybrid orbital. And then the remaining over here, right, these 3 is the 5p MD orbital. Okay, clear? Okay, so foreign just 2s2, 2p, 5. Okay. Step 6, drawing and label and explain. So your drawing very simple, you just have to draw like octahedral. Follow the basic shape. Okay, so this is a drawing. Okay, as I said before, the drawing must be with negative charge as well. Okay. So the explanation is overlapping of sp3d orbital of sp ion, because this is ion, sp negative charge ion with 2p orbital of foreign atom form sigma bond. How are you going to explain this? Actually, based on the diagram, you just check. Okay, so this 6 is the sp. Okay, sp must label for the central atom, and then with sp3d2 hybridization, and then this one, anyone can detect the mistake? Who can tell me where is the mistake for this diagram? Okay, these are all my students' answer, so you can check what is the mistake of the diagram. Common mistake. Okay, anyone? I'm waiting your answer. Here. No label atom. Yeah, label. Sp, fluorine, 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 fluorine. Yes, label everything. Bunyi, this diagram, label everything. The mistake is over here. Because we didn't, we no need to do the hybridization for the terminal atom. So you are using the 2p orbital, this unpaired electron of the fluorine atom, to overlap with the sp3d2 hybrid orbital of sp negative ion. That's why here you just need to label 2p. Okay, 2p. Terminal atom no hybridization, 2p. In your syllabus, we know it to hybrid the terminal atom, 2p. 2p. Be careful, so 2p. Yes, very good, Karen. Yes, 2p. Okay, David, yes, 2p. Okay, Jack, yeah, you are right, 2p. Yeah, please take note. Okay, next. Should be no problem. I just double check the labeling. Central atom, terminal atom, and then the hybridization for the sp3d2, and then the terminal 2p2p. And one more thing, don't forget the pair of electron, the unpaired electron for the sp negative ion and the 2p ion, and then form a sigma bond. Check. This one also the same. Must check. Must label sigma, a pair of electrons, sigma, a pair of electrons, sigma, a pair of electrons. So you have to draw it for 6 times. If you're missing one label, for example, if you forget fluorine, so sorry. So you will lose mark for the labeling. Okay, next. XEF2. So I think should be no problem for you all to draw the Lewis structure. This is the Lewis structure. Okay, I'm going to explain in details. Okay, next. Part 2, molecular geometry. 2 bonding pair, 3 lone pair, Ab2E3. So the electron pair arrangement 2B, 2 bonding pair, 3 lone pair, so 5 electron pair. So the basic geometry refer to 5 electron pair. So it's trigonal bipyramidal. The molecular geometry you have to refer to the central atom, and then there are 3 lone pairs. So the shape will become linear. So you have to draw like linear. So this also can, like this linear also can, as long as linear. Vertical, horizontal also acceptable. And then the bond angle is 180. So the type of repulsion for this structure, here is lone pair, bonding pair. Here is lone pair, lone pair. Okay, so meaning there is no bonding pair in this case. But because there's a three-dimensional, if you check the structure, right, if three-dimensional, right, you will see a straight line. You see a straight line, actually there is a bonding pair, but never mind, just ignore. Okay. Again, type of repulsion not compulsory. I just do it as a package for you all. Okay. The main part over here. Okay, just now there are 2 bonding pair, 3 lone pair. So you check for the structure. Okay, this one X is straight away 8 valence electron. 6 valence electron. And then is trigonal bipyramidal, means 5. 5 means sp3d. So the hybridization is sp3d. So 8 valence electron. Okay. Just now you check. The structure have 3 lone pair. Maintain 1, 2, 3. So maintain the 3 lone pair. And then you need to form 2 bonding pair. This one you need to excite it. So this is the excited state. And then it hybrid. 5 the s orbital and the 3 5p orbital and the 1 5d orbital, it hybrid become sp3d hybridization. And then another 4, these 4 remain as 5p empty orbital. So that's why I say, right, your orbital diagram for central atom must tally with your structure. Okay, so there are 3 lone pair. So 3 lone pair. So you have to maintain the 3 lone pair. Okay, and then you need 2 bonding pair. 2 bonding pair. That's why you must get ready for the 2 unpaired electron. Okay, so this is for the unpaired electron, okay, to overlap with the 2p fluorine atom over here. So this is the orbital diagram. I think should be no problem. Okay, I encourage you all draw a large orbital large hybridization diagram. So easier for you to do the labeling. So double check hybrid sp3d, 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 and then for this one 2p, 2p. Okay, and then terminal atom fluorine, this is a central atom xenon. Okay, and then pair of electron sigma, So the explanation simple. The sp3d hybrid orbital of xenon atom is overlapping with 2p orbital of fluorine atom to form sigma bond. Okay, Okay, next. Still xenon, but this is F4. Okay, so you just follow the step in drawing Lewis structure, so you will get this structure. This is the Lewis structure, and then this is the molecular geometry step. Okay, so this is the molecular geometry sheet. Always remember when you identify molecular geometry is square planar, so must draw it as well. Name and draw. Okay, the type of repulsion. Okay, again, not compulsory. Bonding lone pair. Okay, and then the hybridization sp3d2. Why sp3d2? Total is 6. So 1, 2, 3, 4, 5, 6. So sp3d2. So this is the molecular geometry. The difference is this one with the lone pair at the terminal atom, but this one without lone pair. Okay, and then Lewis structure you don't need follow the molecular geometry shape. It doesn't matter for Lewis structure, but for this one, yes, you must follow the shape exactly. Okay, again. So just now you have to remain 2 lone pair and then 4 unpaired electron. That's why this one is excited. So this one is excited. Okay, so you form this one. 1, 2, 3, 4 will overlap with the 4 fluorine atom. Okay, 1s, 3p, and then 2d. That's why it's sp3d2 hybridization for the xenon atom. Remain 3, 5d empty orbital. So this is a molecular geometry. This is a hybridization diagram. Okay, I think should be no problem. The diagram is not clear, so sorry. Okay, but the explanation is still the same. The sp3d hybrid orbital of xenon atom is overlapped with the 2p fluorine atom to form the sigma bond. So label 2p, 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 2p. At the same time, must label. Okay, this is sp3d2. Make sure all the 6 orbital over here, the 6, even the lone pair, you have to label for the sp3d2 as well. And don't forget lone pair. Some of the students will forget about the lone pair. You must label the lone pair. Okay, for the lone pair. Okay. Okay. Okay, this one a bit different. Just now, without charge. And then this one with positive charge. Okay, so just follow the step, you'll get this new structure. Okay. Okay, so this is the new structure for XEF3+. Okay, you check this structure. I just draw like a T shape. It doesn't matter because this is V structure. But when you transform to molecular geometry, oh sorry, actually this is T shape. Yeah, correct. Sorry, this is T shape. So when you transform to molecular geometry, it also must be like T shape. Okay, some of the students will draw like this. Actually, no need. No need. When you draw the lone pair, you no need to show this one. Okay. You no need to show the loops. Okay, you no need to show the loop. You just show the lone pair for the molecular geometry. Okay, yeah? You no need to show the loops because some of them will show the loops. I don't know why, because maybe they follow the textbook or the international reference book. You just need to show the dot, the lone pair. There are 2 lone pair for the xenon and then 3 bonding pair for the molecular geometry and must name it T-shape. Okay, I think this one should be no problem for you all. B3, E2, 5 electron pair, trigonal bipyramidal, but the molecular shape have to refer to there are 2 lone pair, so T-shape. 1 angle 90, type of repulsion, 1 package, okay, 3, 1 package. If you write the short form, must mention this one. If you write the full term, no need. Okay, again, why showing here? Because we need to check the positive one is referred to which atom. The positive one is referred to xenon. That's why. Next, when you draw the optical diagram, you have to write down is Xe plus. Okay, Xe there are 8 valence electron. One there is a positive, you need to minus 1, meaning that there are 6 valence electron for the central atom. So 5s2, 5p5. And then you check. There are how many lone pair? Forgot already. So there are 2 lone pair. So 2 lone pair, so this one remain. Okay, and this one need to excited. So these 3 unpaired electron will pair with the 2p orbital of foreign atom. Okay, so now as P1, P2, okay, as excited. So 3, 5p and then 1, 5p. So this one is sp3d, 1s, 3p, and then 1d. So what is the mistake over here? 1, 2, 3, 4, 5. So this one is sp3d. Here you have to know that mistake. So this one is sp3d. Double check just now what is the molecular geometry. The molecular geometry is trigonal bipyramidal. 5. Okay, 5. So that's why it's sp3d. Based on here, you should notice a mistake over here. sp3d, sp3d. So this is 5d, empty orbital. So terminal atom for foreign should be no problem. Okay, now about the drawing. This is my student drawing. Actually, she forget about the lone pair, so I add for her. Lone pair, even though this one is T-shape, okay, don't forget there are 2 lone pair. Must label the lone pair over the loops. Okay, sp3d, 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 xenon. Okay, positive charge is the mass, and then 2p, 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 sigma, 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 and then foreign atom. So this is the complete label hybridization diagram for xenon XeF5, XeF3+. So this is the explanation. The sp3d hybrid orbital of xenon ion, this is ion, is overlapped with 2p orbital of foreign atom to form sigma bond. Okay. So the message I want to deliver over here, right? If this one with positive charge, we need to identify the positive is belongs to which atom. Normally it's central atom. So even though xenon with 8 valence electron, if there is a charge here, and then you check, just now you check through the formal charge, the xenon is with positive charge, so you have to minus 1. Now it's xenon positive ion. Okay, this concept is the same. Okay, but I want to ask you, how about what is the problem of this restructure? Don't draw like this. Okay, you have to draw like this. Here. When you draw the Lewis structure, don't join the bonding pair and the lone pair. Okay, you have to draw like this. Okay, positive charge is belong to this one. And then when you draw the positive, when you show the charge, right, must write down positive. In this case, formal charge must be positive or negative sign. Okay, must show positive one. Okay, and then so A, B, E1, yes. Okay, 5 bonding pair, 1 lone pair, so is of 6. So 6 is octahedral, correct? And then with 1 lone pair, square pyramidal, correct? And then type of repulsion, bonding pair, lone pair, and lone pair. Okay, so when you write down in short form, right, you must state like this. Let bonding pair is bonding pair, lone pair, electron pair, electron pair. Okay, and then the bond angle, okay, like this is 180. Okay, like this is 90. So this is the molecular geometry for the XeF5 plus. Attention please, meaning that you have to identify some mistake. Okay, so octahedral sp3d2. Okay, just now there are how many lone pair? 1 lone pair, 5 bonding pair. Okay, so you have to remain this one for lone pair, this one excited, so that can form 5 unpaired electron which can overlap with the 2p unpaired electron of chlorine atom. Okay, this is my student answer. Who can identify what is the mistake for this diagram? What is the mistake for this diagram? This is the molecular geometry. This one is the molecular geometry. This one is the molecular geometry. So please identify the mistake. Okay, if you compare what is the mistake for the molecular geometry for XeF5 plus with this hybridization diagram. No lone pair shape. Yes, Muhammad Iqmah, you are right. Yes, my students so excited. Yeah, okay. So always remember sp3d2 is 6. You must have 6 orbital, but here only 5. You forget about the lone pair over here. Okay, so if there are 6, right, so you must draw the lone pair as well. Okay, so use my label sp3d2. Okay, very difficult for me to write, but very good. You identify no lone pair shape. Yes, very good. Okay, so the rest is the same. Okay, make sure always check your hybridization diagram with your molecular geometry and check your molecular geometry with your Lie structure. It's tally, everything tally. Okay, when you want to draw this and then check for your central atom, is it tally? So I need 1 lone pair and then 1, 2, 3, 4, 5. I need 5 unpaired electron. Yes, 1, 2, 3, 4. So 1 lone pair and then 5 unpaired electron. Always tally. Okay, so this is the correct overlapping diagram. Okay. So now let's check. I show you 5 examples already. Okay, 1 with negative charge. Okay, 2 with positive charge. And then even though these 4 with the same central atom, okay, but to check, these 5 electron pairs, 6, 5, 6, and then all with different number of bonding pair and lone pair. When it has a different bonding pair and lone pair, meaning that the electron pair arrangement and the molecular geometry you check all different. It's totally different. Okay, so you have to take note now. Okay, and then let's check for the this one is not really important. If you check octahedral, since all with the same terminal, that's why it's non-polar. Okay, and then this one with same terminal, and then this is linear, still the basic non-polar. Okay, square planar, just as I mentioned, this one with lone pair, but it's square planar, non-polar. Okay, T-shape with lone pair with T-shape with 2 lone pair cannot cancel off. Okay, this is polar. Square pyramidal cannot cancel off, polar. Okay, yeah? And then hybridization is depends. Okay, always remember when you want to check the hybridization always refer to here. Okay, refer to this. So 6 electron pair octahedral sp3d2. 5 electron pair trigonal planar sp3d. Okay, and then be careful for the central atom. You have to check This one with negative charge. These two without charge, that's why it's neutral atom. This one with charge, positive charge. This one with positive charge, positive charge, positive charge, positive charge. Here, so this is summary of one you identify. Even with same central atom, all the shape is different. Okay. So, this one all is kacang putih, should be no problem for you all. How about this one? Just now, just with one central atom. For this structure, there are three central atoms. Okay, how are you going to draw this? Of course, step 1 Lewis structure, step 2 molecular geometry, but there are three central atoms, so you have to show everything. Okay, everybody, please pay attention. Okay, the highlight of today's lesson is here. And then step 3, 4, 5, step 6, 7 should be okay. The step is the same. Okay, so first, you must start with a Lewis structure. Sometimes the structure might be given, sometimes no. Just give you the molecular formula like this. If the question just give you the formula CH3COOH, then you have to draw as usual. Calculate the total number of valence electron. So 24 minus 14. Why 14? Because you form the bonding pair. 1, 2, 3, 4, 5, 6, 7. Okay? 7 times 2, 14. Equal to 10. Okay, make sure the terminal. Hydrogen, duplet, duplet, duplet. So you have to form the octet for the terminal over here. And then this one, okay, not achieve octet yet. Okay, you assign the electron for the oxygen. So minus 10. Must check. Carbon haven't achieved octet yet. That's why we need to form double bond. Okay, to ensure that the octet. Okay. So in this case, actually it's carboxylic acid. Okay, this is methanol acid, no, ethanol acid. So it will form the double bond over here. So this is the correct structure. Okay, the question asks about hybridization, overlapping. So before you proceed, right, actually you can analyze. For this one, 1, 2, 3, 4, 4 bonding pair. I know it's tetrahedral, sp3. If the question asks about, please state the hybridization hybridization for carbon atom, you just state sp3. That's all. If the question asks about state. Okay, and then for this case, 1, 2, 3. 1, 2, 3. Always remember multiple bond considered as one bonding pair. Multiple bond considered as one bonding pair. So 1, 2, 3, 3 bonding pair, trigonal planar sp2. Okay, for this one bonding pair, one bonding pair. So there are 2 bonding pair, and then lone pair, lone pair. Total is 4 electron pair. So this is tetrahedral sp3. Over here, I just identify the basic electron pair arrangement first. Because for the shape, right, we just refer to the we need to refer to the electron pair arrangement. Okay. So now, yeah, step 2, molecular geometry. So we must label, since there are 2 carbon, you label this one as C1, this one is C2, this one O1, this one O2. Okay. So this one you check by yourself. You have to assign, have to explain each of the central atom. Okay, you have to refer each of the central atom. One is for the C1, C2, O2. Okay, thank you, Kusha. Voice clear? Okay, so follow the step. Again, you let BP equal to bonding pair if you do this if you write down the short form. Okay, now we go for this one. So C1 just now is tetrahedral. That's why you need to excite it. Tetrahedral, you need to form 4 bonding pair. So one of the electron excited. Okay, so sp3. Next, C2, sp2. Okay, it needs to form 3 sigma bond. So this one is for the pi bond. So we write down as unhybrid orbital or pure orbital. Okay, this one, sp3, there are 2 lone pair and then 2 unpaired electron. In this case, no need excited because it's enough. Okay, it's enough because I just need 2 bonding pair and then 2 unpaired electron is enough. That's why it just remain no excited state. Okay, next is for the terminal. This is the O1. Okay, and then this one is the hydrogen. 1s. Okay, Since you are using the short form GS for ground state, excited state, and then HS for hybrid state, right? So you must stick this one. If not, please write down the full term. Okay, excited state, hybrid state. Okay, next. Based on this diagram, how are you going to draw the hybridization state? Okay, have a look up. Okay, this is sample 1. This one is sample 2. Check for sample 1 first. C1. 1, 2, 3, 4 tetrahedral overlap with the hydrogen. Okay, so must look like tetrahedral. And then C2 trigonal planar. So this is a trigonal planar. Okay, and then form the pi bond with the O1. So this is the pi bond. Always remember, pi bond must be parallel. Must be parallel. Kata selari ya, mesti selari ya. Parallel overlap. And then next is the hydroxide, OH. So this is the O2. This one is the O2. And then is the hydrogen atom. Okay, if you draw like this, right, you will check the cross is like this. Nothing wrong is correct, but you will overlap and then you will touch the looks for the other orbital. Look at another example. I prefer like this. For me, I will draw like this. I will settle the pi bond first. Okay, I know C2, there is a pi bond, so I draw the C2 first. So it will overlap with the O1 to form the pi bond. Okay, and then don't forget, you have to follow the shape correctly. Exactly follow the shape. You have to follow. Okay, you have to follow the shape. This is tetrahedral. Okay, so here is trigonal planar. The O2 is trigonal planar. Here with lone pair, lone pair. And then this one also must like trigonal planar. Oh, sorry, tetrahedral. Sorry, tetrahedral. Here is tetrahedral. Here also tetrahedral. Tetrahedral, tetrahedral. Okay, so these two have the correct shape. Okay, these two diagrams have the correct shape. Depends on you which one you prefer. Okay, if for me I will draw like this, I will settle the pi bond first. Okay, so that it won't cross the other orbital. So let's check the proper answer. Yeah, this is the proper drawing. Okay, everybody, I give you 1 minute. Go through the diagram and check the explanation. So I will put the Louis structure over here. You have to check, you tally back. So the C1. Here is the C1. Here is the C1. Tetrahedral sp3. Overlap with 3 hydrogen atoms. 1s, 1s, 1s. And then this is C2. C2 is over here. Okay, C2 trigonal planar. And then this is the pi bond, pi bond. This one is a 2p orbital. This is a terminal atom. Okay, and then at the same time, okay, don't forget there is another oxygen atom. Okay, here there's another oxygen atom with tetrahedral shape. This is the oxygen, tetrahedral. There are 2 lone pair, and then overlap with 1. Oh, sorry. Sorry. Okay, sorry. Here is the O2. O2 over here. Okay, this is the O2 with tetrahedral shape, 2 lone pair, and then overlap with 1 s hydrogen atom. Okay, now we check for the explanation. For overtime already, okay. This is almost last already, So 1 is the explanation. sp3 hybrid orbital for carbon atom is overlapped with the 1s orbital of hydrogen atom to form sigma bond. Okay, number 2 is here. sp3 hybrid orbital of C1 atom is overlapped with the sp2 hybrid orbital of C2 atom to form sigma bond. And then number 3 is here. The sp3 hybrid orbital of O2 atom is overlapped with the 1s orbital of hydrogen atom. And then the 4 is the sp3 hybrid orbital of O2 atom is overlapped with the sp number 4. Oh, okay, number 4 is sp3. Okay, there is some mistake here. Is it correct? Oh, I explain this one. sp3 hybrid orbital of carbon atom, the C2 atom, is overlapped with the sp3 hybrid orbital of O2 atom to form sigma bond. Okay, and then the fifth one is this one. The sp2 hybrid orbital of C2 atom is overlapped with the 2p. Over here is the 2p, pure orbital D, because this is the terminal atom to form the sigma bond. The last one is pi bond. Always remember for the pi bond must label the unpaired electron up, down, overlap, and then form one pi bond. Okay, so that's all for hybridization. Okay, this one you can try it by yourself. Very simple. Based on here, I know already. So here there is a lone pair, lone pair. And then here there is a lone pair as well. You have to familiar already. And then this one is trigonal planar. And then this one is tetrahedral. Okay, so you have to draw it according to the shape. So this one is sp2, trigonal planar. This one is sp3, tetrahedral. So you just draw it accordingly. Okay. Okay. Yeah. Part D, intermolecular forces. So for this one, you must know what is hydrogen bond, what is van der Waals force, and then under van der Waals force there are two dipole-dipole interaction or permanent dipole for polar molecule, and then London forces is for dispersion forces or London dispersion forces is for non-polar molecule, and then this one exists for polar and non-polar molecule as well. So if you want to know the details of this part, you can refer to my video on. You go to playlist chapter 4 chemical bonding, you can search the video for hydrogen bonding van der Waals forces. And then the van der Waals forces is affected by molecular size is the main factor, followed by molecular shape, about the linear shape and the branches shape, and then the molecular polarity. Okay, this one is related with what we discussed just now, polar or non-polar. And then hydrogen bonding is depends on the electronegativity, FON, fluorine, oxygen, and nitrogen atom. Okay, based on the hydrogen bonding, we need to explain the physical properties for boiling point. For the molecule with hydrogen bond has higher boiling point because hydrogen bond definitely is more stronger than van der Waals forces. And then you have to explain the solubility and density of water based on hydrogen bonding. Okay, for part E, properties of matter. So this is four physical properties of matter: malleability, ductility, electrical conductivity, and thermal conductivity. So you must know how to explain each of the physical properties, and then you must know how to draw the diagram as well for the malleability and ductility, because when you explain like substitution force or any stress is applied, so it can slide over another layer without disrupting. Okay, means the positive ion and the atom of the matter still maintain as usual. Okay. During exam, right, question tend to ask you explain the formation of metallic bonding using the electron C model. So when you have to explain by using the electron C model, means you have to draw it and then label for this is a positive sodium ion, and then the rest is the electron. Make sure that the number of electron tally with your ion. If there are 9 sodium ion with positive 9, okay, means positive 1 times 9, so there must have 9 electrons as well. Okay, and then the question will ask you why aluminium has higher boiling point than sodium. Okay, you have to know the strength of metallic bond is directly proportional to the number of valence electron per atom, and the radius inversely proportional to the size. Okay, aluminium 3 valence electron, and then aluminium has the smaller size compared to sodium and magnesium. So these are the reasons. Okay, let's think about it. How about the boiling point and melting point for group 1 and 17? If I ask the question about chapter 3, do you still remember what happened when going down group 1 for the boiling point and group 17 for the boiling point? How to explain? You go to find it. Going down group 1, the boiling point decreased. But going down group 17, the boiling point increased. Why? Actually, this one is your form 4 periodic table as well. Okay. So the difference, because the structure, the element is different already. Because group 1 is matter, group 17 is non-matter. So matter is depends on the interparticle metallic bond. But for group 17, it depends on the intermolecular van der Waals forces. Okay, and then metallic bond stronger than van der Waals forces. That's why compare boiling point between group 1 and group 17. Group 1 and group 17, sure group 1 is higher. Okay. Then how about the boiling point or melting point of the element across period 3? Ta-da! If the question asks you, well, how about the boiling point or melting point of the element across period 3? This is the answer. Okay. So we check. Okay, sodium, magnesium, aluminium, metal. So you have to talking about metallic bond. This is metalloid, giant covalent structure. And then these all are non-metal. So we talk about van der Waals forces. Okay, so this is the answer. But I try to summarize you all like this. You must identify the structure. 3 of them with different structure. These 3 categories with different structure. So and then with different interparticle forces. So the explanation is different. Okay, for metallic bond, you have to talk about electrostatic forces between the positive metal ion and the delocalization of negative valence electron, which we discussed before, and then directly proportional to the number of valence electron and inversely proportional to the size. Okay. For this one, you have to talk about covalent bond, and then it will hold together or join together with a 3-dimensional area, tetrahedrally bonded. Okay, here this is a tetrahedrally bonded structure for the silicon atom. So high energy is needed. Okay, for the simple molecular structure in the non-metal, is talking about van der Waals forces depends on the molecular size. When the molecular size increase, the van der Waals force increase. Okay, you have to refer over here. We are talking between the chlorine molecule and the chlorine molecule. This is the van der Waals forces. If chlorine atom with the chlorine atom, the Cl2 over here, this is the covalent bond. If intermolecular forces over the chlorine and chlorine atom is covalent. But the chlorine molecule and the chlorine molecule is the van der Waals forces. Okay, I think that's all. Yeah, that's all for today. So again, this is the revision tips. We still have time. Please go through all the past year questions and then take out your real exam past year book, study all the questions. The final tips, now you should study past year. I think to lecture notes, tutorial, your own notes, you've done already. This one, no need to, you settle already. No need to go to refer your lecture notes anymore. You have to study past year. Okay. What I mean is, if you study everything already, you know everything already. Now you focus the tips and tricks based on your past year question. Here, if you have any question, please don't hesitate to consult with your chemistry lecturer. Okay, now let's check. If you have any question, you can comment. I will try to answer. Okay, Carol, tell us, whether will there be definition question in your PSPM? Okay, there is no definition question, but I would like to ask you. If the question asks you, okay, oxygen. Oxygen, there are 6 valence electron, right? Okay, please explain the electronic configuration for oxygen atom. Okay, you need to draw the orbital diagram, or you need to explain in terms of SPTF notation. So you have to explain in terms of alpha principle. You have to explain in terms of Hans rule. You have to explain in terms of Pauli exclusion principle. So you need to memorize the definition. The question didn't ask you definition, didn't ask you about define, but ask you to explain. So do you need to apply the concept for the alpha definition, Hans rule definition, and Pauli exclusion definition? Yes or no? Okay. Another example. If the question asks you to chapter 7, okay. If the question asks you, okay, write down the equation. Okay, write down the equation for the reaction. You have to identify which one is acid, which one is base. But you cannot identify which one is acid, which one is base if you're not sure the Bronsted-Lowry acid and Bronsted-Lowry base. So definition won't be asked during exam, but the question will change or twist in order, the question will twist to another form. Okay, so you need the definition to help you, to assist you to answer the question. Okay, get it, Carol? Okay, soalan definasi tak akan tanya, tapi dia buatkan suruh you explain, jelaskan. Semasa you jelaskan, you memang kena guna konsep definasi juga. So, jadi definasi you kena tahu. Okay, okay. So, thank you 68 of you follow my class. Okay, almost one and a half hour. Okay, if no question, then we will stop here. Okay, thank you for joining. Good luck and all the best. Okay. Okay, this is another question. Fatin Jamil. And then in Lee structure, do we need to write formal charge? If yes, can we just write a small number beside the element? I know what you're asking about. Okay. Okay. Okay, for example, I know Jamil is, Fatin Jamil asking like this. Okay, you know this is -1, right? Meaning that you want to write down the, okay, this one +1 is here. Okay, this one is +1. You want to write over here. And then the chlorine, the nitrogen is -2. You write over here. Okay, no. The answer is no. Okay. Maybe you can use your pencil to assign over here, but I don't encourage. Better don't. Okay, you have to just show the overall charge. Okay, this one don't. This one don't show. Okay, don't show like this. Don't. Okay, Jamil. Fatin Jamil can. Okay, can we just write a small number beside the element? No need to like this. Okay, you just show this one. Okay, the formal charge. Just do the formal charge over here. Okay, just do the formal charge at the outside of the structure. Okay. So others question want to ask? Can madam, can. Thank you so much. Okay, yeah, answer. Yeah. Okay. Actually, chapter 4 is very simple. Compare to chapter 1, you a lot of calculation. If you clear about the calculation, actually chapter 1 also okay. But chapter 4 is about the concept in drawing. Start from structure. Lee structure is the main part for the whole chapter. Okay. Once you know the Lee structure, and then you can proceed for the molecular geometry. For molecular geometry, you have to memorize the shape, the angle of the shape. Then you have to proceed for the orbital diagram and the drawing. So part A, part B, part C actually is synchronized. Jared Thomas, you asked me this question. Oh my God. Madam, the central atom is more electronegative or less? We choose the more electropositive atom as the center atom. Choose the positive one, dear. Jared, choose the positive one. Okay? Okay, choose a more positive one and positive. Okay, so if you look at here, okay, carbon is more positive compared to electropositive compared to sulfur and nitrogen. Because this one is group 14, this one is 16, this one is 15, 14. So group 14 is more electropositive. Okay, still got 2 minutes before 10 o'clock. Okay. So may I know all of you come from where? You can leave your comment. You are from Camp PK, Camp L, or Camp PH, or Camp J. You can leave your comment over here. Okay, so that's all for today. Thank you. Okay, don't forget, please. Okay, good luck and all the best. And then please subscribe my channel. Okay, please press the subscribe button. Thank you. Oh, from India, Strandy. Okay, KMNS. Okay, Nana, I know you from KMP. Okay, bye. Okay, hope you all get something. Okay, bye. Oh, Hafiz from Camp L. Oh, Camp Sarawak, Ikma. Okay, bye. Welcome. Good luck. Bye, Alicia. Bye, Farhaida.